I'm sorry, Brady, but you just no.
All right, last one. We'll go through it quickly. Population, 10 to 15% of the AP exam. Before I start this though, next week we do the pollution section, and your last test is pollution. So the packet you're going to get next week is everything you need to know for the test. So you're basically going to get a test review next week when you come to the review. Just the FYI. It's on the Friday. Right now. It's like in 2 weeks. All right, so population. Yeah, group of species in the same geographic area at the same time. You gotta remember it's at the same time. Population density, it's the number of individuals in a specific area. So right now, in this room, the population density is high. Usually there's only about 20 people. That would be a lower population density. Population dispersion, there's either random, clumping, or uniform. Biotic potential is the amount that a population would grow if there were unlimited resources. And that's going to create a J curve.
Right.
Carrying capacity is what's going to cut that J curve off and turn it into an S curve. So when you reach the maximum population size that can be sustainable by the ecosystem, then it's either going to level out and turn into a J curve, or it's going to overshoot, use too much of the resources, and drop and die off. One of those two things.
What would be a good example of a population that reached this carrying capacity?
The best way to think of it is, well, I think of it, I mean, they're going to ask humans, but the way that I think of it is a bacteria on a petri dish. You put one bacteria on there, it's going to double, which is going to create a J curve. And then at some point, there's not going to be any room left, and it's going to have to balance itself out. It's not going to keep continuing to reproduce and making more. It's just a limited area. That's the easiest way that I remember. They will ask stuff on the human population.
Right.
So that's where they're going to draw in both resources, and then they might talk about different laws and customs in different parts of the world. You can talk about like China's one-child plan, and how in Germany they're actually having less kids, so the population is decreasing. So they're trying to get people to reproduce more, have more kids. So biotic potential shows exponential growth and is called J curve. It's this, and that happens. That's not there. These two go together. That's the number to memorize. The population of the world is about 7 billion approximately. So they always ask that. It's going to be clear on the multiple choice. They'll have 2 billion, 150,000, 18 billion, 6.9 billion. So it's going to be, it's not going to be like 6.8, 6.9, they're going to make it clear. It's about 7 billion. So they always ask that question. This is another good number to know. There's about 311 million people in the U.S. And then immigration, people are going out of population. Immigration, they're going in. So if you think I in, E exit. So immigration, they're going out. Immigration, they're going in. So if you're going out of this room, which you're going to do in a minute, that's emigrating out. When you came in this morning, that was emigrating in.
Okay, should we consider that the United States is a country with the third largest population?
Maybe, why not? You know, it's all right.
All right, principles of population ecology. Population ecology is a branch of biology that deals with the number of individuals of particular species that are found in an area and how and why those numbers change over time. So they ask these questions. How many people in the population? Are its numbers decreasing or increasing? What is its pattern of reproduction? What is its pattern of mortality? Its death rate. Population density. How many people individuals are in an area at one time. You need to know the area. So this has a higher population density than that. In both cases, there's 20 of those individuals, but this is a larger area, this is a smaller area. So if all of us were to go outside, a little bit, that would be a smaller or less population density than us all being in the classroom at the same time, because the area is bigger. So this is a closed system. So in a closed system where things can't come in and out, the only way population increases is through births, and the only way population decreases is through deaths. What's more realistic is an open system. So it could be South Florida, it could be Florida, it could be the United States, it could be Broward County, it could be this room, it could be Davie, it could be the school. Those are all open systems. Not that anybody's going to be born on this campus, I don't think. But births, plus anybody that comes in, that's going to increase the population. Deaths and anybody that goes out is going to decrease the population. I for N, E for X.
We need to decrease the population.
So this is a global scale. Don't remember this one, or remember the more complicated one,
Yeah, the one with
and you'll get it right, because it includes all of it. All right, so growth rate R is equal to birth rate minus death rate plus immigration rate minus emigration rate. So that one you're going to want to remember, because they'll have a basic calculation for that. And if they don't say anything about emigration or immigration, then you know to just focus on this part. And they can ask you to solve for any of these. There's actually two versions. Because order operations, you can, but don't worry about that. Maximum population growth, biotic potential or intrinsic rate of increase is the maximum rate at which a species or population can increase under ideal conditions. It's like the petri dish. If it were infinitely big, that bacteria would have biotic potential increase, rate of increase. Yes. So this is the bacteria. Nice. And it makes a J curve. J curve. Exponential growth. They all mean the same thing. They can't do it forever.
Okay, I like that. It's very quick.
Quick and to the point.
So there's environmental resistance. Exponential growth cannot occur forever. What factors prevent it from doing so? Carrying capacity. So a lot of times with the population section, they're going to ask you graphs, to interpret graphs. They may ask you to write a graph, but they can ask you to interpret it. So they could ask the time at which it reaches carrying capacity, which would be right here. They could ask the number of species, which would be here. They could say when does it really, there's a lag phase, which is down here.
Mr. Stackhouse,
Yeah.
what's the main factor in preventing the human population from continuous exponential growth?
Limited
Food.
resource.
Huh?
Yeah.
Food?
Limited food, diseases, things like that. That makes an S-shaped curve. Carrying capacity, it creates an S-shaped curve. It balances out the population. Lag phases in the early part, and it's getting small population getting going. Then it goes exponentially, then it turns into logistically. So S-curve is the oversimplification of how most populations change over time. If it doesn't do an S-curve, it's going to die out. It's going to overshoot and fall really quickly.
So like the up-down Z curve.
Yep.
Just like
This
that.
is an example of how a species of reindeer died out. So they went up, they're doing the J-curve, they should have reached carrying capacity, which would have been around here somewhere, and they should have leveled out, but something happened, they overshot it, and they all died out. So that's what happens if you don't reach carrying capacity.
Santa's not coming this year.
Do we know the causes of that, Mr. Stackhouse?
Santa didn't feed them enough.
The decline of reindeer? No?
All right, this is important to know. K-selected versus R-selected. These are called life history strategies. R-selected, if you want to think of, I think of frogs and tadpoles or fish as R-selected. And then you want to think of humans or elephants as K-selected. So if you think of frogs, there's a high growth rate, they grow fast. If you think of people, or let's say elephants, there's a slow growth rate. Small body size, large body size. Early maturity, so they develop early in their lifespan. Late maturity, they develop later on in their lifespan. Short lifespan, long lifespan. Large broods, that means large numbers being born at one time. Small broods, that means you only have like one, sometimes two babies at one time. Like a dog would be right in the middle.
Why?
Dogs usually have 5 to 6, depending on the breed, puppies at one time, which compared to a frog population, which have hundreds at one time, or an elephant population, which has one at one time, it's like right in the middle. Its lifespan's about halfway through all that. Little to no parental care, so the parents lay their eggs, or usually that's how it happens. The parents lay their eggs, and then they leave. High parental care, the baby, usually most mammals are in this category. They, the babies have to stay with the mom and nurse and that stuff for a while.
What about sea turtles? Is there like
Sea turtles would technically, if there wasn't an issue with them going the wrong way because of the light drawing them the wrong way and there wasn't a lot of predators, they would be closer to R-selected. But in reality, when you take all the factors that realistically are there because they'll go the wrong way, things will eat them, only like 1 or 2 survive to maturity out of like 100 eggs. And actually something interesting, you got me off topics. I went with my nieces, they came to visit like over the summer, and they wanted to go to a turtle release. And because I'm an environmental teacher, I can get my nieces in their turtle release. So what they do is they'll have like, they don't have a lot of people, you have to have like invitation. Sit there and they go and they take these baby turtles that just hatched the day before, and they put them in a barrel, and then everybody goes and like at dusk, and they release the baby turtles that were born the day before. And then you watch the little flippers go towards the ocean, they float away. And there's a bunch of kids, they were all like elementary school kids and their parents for the most part. And my nieces are like 9 and 12 or something. So they, I don't know, somewhere around that age. And what was funny was my sister and I were laughing because what they did is they put all the turtles down and then like 5 or 6 out of 20 going towards the water. Then they start moving the other ones a little more towards the water, and then we're laughing because they were dead. And they didn't realize it, and the people were saying, "Come on, go, let's give them a little help." And they wouldn't say it, they were just there going,
That's not really funny. It's pretty cool. No,
and they start floating away.
it's not funny.
But
It isn't cool.
it was funny when, no, it's not funny.
Thank you.
It's funny when you see a bunch of, it's not funny from the child's perspective, but it's funny from the adult perspective, knowing something the child doesn't know and observing their reaction, knowing that they don't know something that's a reality of life. That was what was funny.
It's
In a twisted
it's
way.
goofy, but it's not really.
No, it's not. It's morbidly funny. You have to have a weird sense.
I don't share that dark. I am very.
All right, there's 3 general types of survivorship curves, type 1, 2, and 3. This one's 3. So at a young age, they die off. It's usually R-selected. Type 2 is right in the middle. Type 1, the babies live to old age and then they die off in old age. That's what they say. So these are usually R-selected, these are usually K-selected, and these are kind of in between. Yeah. Density-dependent factors. These are things that affect a population. The larger a population is in a smaller space, so the higher the population density, the more disease and predation can occur. So during the Black Plague, there was high population in Europe. Places that have the high population, like these major cities in Europe at the time, I think it's like 75% of the people died because it was a high population, but if you lived in the country, you usually survived. So that's an example of disease affecting, as a density-dependent factor affecting the population. Predation, you can think of like planet Earth when it's like a lion going after the gazelles. That's predation
Because there's
using a large population. The larger the population, the more likely one's going to get caught. So that'd be
There's like a
yes.
there's like a higher concentration of predators, like
Higher concentration of prey.
preying.
Well, it actually can go either way. But if there's more prey, then there's more likely a chance that the predator is going to catch the prey. Density independent factors means it doesn't matter what the population is, and that's all what insurance companies call act of God. Mainly, it's like fires, floods, hurricanes, any natural disaster sort of thing will affect a population, whether it's a large population or small population. So like hurricanes, fires, earthquakes, things like that. Just want to read this. Yeah, okay, don't worry about that. They may ask you to interpret what's going on, so you should be able to interpret what's going on with first of all, you need to know the wolves are the moose are the prey and the wolves are the predators, and you should be able to interpret this. And they may have like 1, 2, 3, 4 and say what's happening. That would be that, what I call it, the matching, the glorified matching. What do I call it?
So
Glorified matching. The question, sophisticated matching. The first question will say, what is happening in A? What is happening in B? What is happening in C? And then you choose which answer it is.
Right.
That's usually how it's going to work.
That seems easy enough.
Yeah.
It's just maybe it's passing, maybe that hard.
there's always more prey than predators, for the most part.
Yeah.
If that's the case, you're going to overshoot and the
Right.
prey population is going to die out. So it's not going to reach an S curve. Human population size, oops. Yeah. What's the human population size?
7 billion?
7.
10.
It's about 10.
If you want to know exactly how much, whoops.
Yeah, there we go. There we have it.
Oh, wow. Look at that.
Yeah. A lot of babies being born all of a sudden.
Which is
higher, heavier
I like this one better.
Oh, God. And if you look closely, you'll see most of that's happening in China.
That's kind of babies being born. Wow,
That's the first time I saw that.
Yeah.
It's good.
Not as many of these just happen in China.
Yeah, I know. You're right. It's a combination of factors.
7 billion, 80,000.
It was today.
You need to know kind of what's going on in history for population questions like World War I, World War II, the invention of vaccines and antibiotics, medical care, things like that.
The baby boom. What's with the dotted lines switching?
These are predictions.
If we go too high up, will we eventually just die?
Yes, unless we can alter how much food we're producing, medical
we're
care, the amount of
I just
space.
need to kill off a certain amount of people so we don't all die.
Great, that would go with that ecological worldview that we can talk about.
We can't just kill people.
We have no solution.
All right, you want zero population growth. That's what your goal is for every population. You don't want the population dying off. If it's a negative number, that means it's decreasing in size. If it's a positive number, which most populations of humans are positive numbers, that means it's increasing. But what you want, ideally, is zero population growth. That way you can have medical services and all that stuff predicted and ready when you need it. Okay, yeah. Go look at that website. Highly developed countries, low infant mortality rate, developed have high. Different demographics. Sure. You should know the different stages: pre-industrial stage, transitional, industrial, post-industrial.
Which one had the highest birth rate?
Yes.
All the stages?
Yeah.
Pre-industrial.
Industrial, look at sheets, it's right there. Yeah, the transition from pre-industrial.
Transition from pre-industrial.
Okay.
That's where it has the highest.
So you should know what's going on. Definitely know the population growth graph. Age structure diagrams. So know that if it's a pyramid shape, it's expanding, and that's like a developing country. If it's stable, then it's not growing or decreasing. It's always going to equal 0. If it's declining, that means it's more like Germany or Japan, and there's less than 2 individuals per couple being born, averaged out. So replacement level fertility is going to have that middle one that's going to not have any increase or decrease. So this is an example of a developing country. So this is the kids down here, and then the older you get. This is the United States. This is during the baby boom. I forget
There were more
years
females.
in there, but this is during the baby boomers right there. And Germany. Yep, we have high developing. Yeah, those are all that. There's that. Total fertility rates, yep, you should know that.
Wonderful.
There's a lot of stuff we should know.
I only like this finger, watch.
Yeah, there you go.
It doesn't work with this finger.
And right when you say that,
There we go.
Working.
You gotta push like a button. Typically fertility rates are high in developing countries because of gender-defined roles of women are supposed to stay at home and take care of the kids.
And the
In
guys
general,
have nothing.
higher fertility, compensate for higher infant mortality. Yeah. What's up?
it looks like there's a lot of stuff we should know.
Yep.
You're so mean. Stackhouse.
Yeah.
So the reduction of the total fertility rate should have more to do with promoting education or promoting, would that lead to birth control or
Education is the best way to control population.
especially women? In many countries
Well,
considering.
It's equal,
It's equal.
but
Considering gender inequality that you're talking about right there.
yeah, I'm not gonna get into that.
I know, but
We
it's,
could get into a big debate.
That's what he's
it's not what I want to learn.
This is a generalization. The more educated a woman is, the less kids she generally has. So this stuff doesn't need explanation. You can understand this. China has a policy, 1 kid per family. It's,
Yeah, you get better benefits.
you do get better benefits. The less kids you have, the better benefits the family has. So if you have 1 kid, think about it. If there's a family of 2, a mother and a father that both work and they both make $100,000 a year, if they only have 1 kid, they can both have a BMW or Mercedes. If they have 3 or 4, they have to get
station one.
station wagons.
Sorry, mom, man.
These kids are expensive.
From what I've heard, it's both parents can, if both were single children, they can have a second child, but if their parent before them had a second child, they can't have a second
Yeah, because it
child.
kind of cancels itself. Yeah, that's true.
So in China, would you say it's actually significant that they kill a lot of female babies? They will actually kill them just because they want to have a one.
They tax them more.
They need to get a permit for the
They don't-
second child.
They don't kill them.
They tax them, if you have more kids, you get taxed more heavily. It's not that they say you can't have the kids.
Right, so why is there a disproportionate number of males?
That part is because of the pollution.
Right.
So yes, but let's not get into that. You guys can read and understand this. Let me see what else is important.
So Stackhouse, wait, I want to talk about Nigeria. No. It's an interesting case study.
No,
Not at all.
so a person's ecological footprint is the average amount of productive land and ocean needed to supply that person with food, energy, water, housing, transportation, waste disposal. You want a small ecological footprint. You don't want a large one. That's one of the main ideas of environmental science, is how to reduce a person's ecological footprint. So that's it for that. Next week,